In algebra, symbols and letters are used to represent numbers. The letters may be A, X, theta, etc. Now, these letters are referred to as variables because they assume different numerical values, or we say they change. Actual numbers like 5, -3 are called constants because they do not change. Algebraic expression is simply the collection of these letters and numbers with at least one mathematical operations like addition, multiplication, division, and subtraction. Now, example of algebraic expression is 5x squared y minus 2x plus 7y minus 3 and 6x squared y. These are examples of algebraic expressions. In algebraic expressions, the individuals are referred to as term. So, for instance, this is a term, this is a term, and a term. The terms are separated with minus sign or addition. Now, in algebraic expression, the multiplication and division signs don't show. For instance, if you have 2a, is the same as 2 times a. So the times or the multiplication sign did not show. And again, we have 3a over b. The division sign here is also not showing. It's the same as 3a divided by b. Now, if you have a number multiplying a variable like the 2a, the number multiplying the variable is referred to as the coefficient of the variable. So the coefficient of a here is 2. The coefficient of x here is -2. The coefficient of x squared y here is 5. Now, in multiplying terms in an algebraic expression, for instance, x times a times 5 times y. When you multiply, it is not x, a, 5, y. No. Always the number comes first. So it's going to be 5. And then you list the variables in alphabetical order. So it's going to be 5, a, x, y. Forming algebraic expressions. I think of a number. What is 1? Half the number. 2, 7 times the number. 3, 10 less than the number. 4, 8 more than the number. 5, 2/3 of the number. Do you know the number? No. So we say, let the number equals x. So let's tackle the first one, which is number 1. We are told that half the number. So half the number x is either written x over 2, or we say 1 over 2x. Let's look at the second one, number 2. It says 7 times the number. So 7 times the number is 7 times x, which is equal to 7x. Number 3, 10 less than the number. So number 3, 10 less than the number. So the number is x. So 10 less than the number is minus 10. Number 4, 8 more than the number. So it's either you say 8 plus x, or you say x plus 8. Finally, number 5, 2/3 of the number. 2/3 is 2/3. Of in mathematics means times. So 2/3 of the number is finally 2/3x. Number 6, 3 times the number less than 10. 3 times the number is 3x. Less than 10 will be 10 minus 3x. So this is 3 times less than 10. So number 7, theta less than 2 times the number. So this is 2 times the number. So theta less than 2 times the number is 2x minus theta. Number 8, 1/5 of the number less than alpha. So 1/5 of the number 1/5 of x less than alpha. So it's going to be alpha minus 1/5x. Number 9, 1/3 of the number. So this is 1/3. 1/3 of the number. So 1/3 of the number more than 5. So it is 5 plus 1/3 of the number, or 1/3 of the number plus 5. And finally, number 10, 6 times 5 less than the number. 6 times 5 less than the number. So 5 less than the number is x minus 5 is 5 less than the number. So 6 times this is going to be addition and subtraction of algebraic expressions. In algebraic expressions, you group like terms and you simplify the like terms. So let's look at some few examples to make you appreciate. So 7x plus 2 minus 11y plus 3x minus 2y minus 8. Okay, so this is an example of algebraic expression. So we group like terms. So what are the like terms? 7x and then plus 3x are like. And then we have minus 11y and then minus 2y. Yes, and then we have plus 2 and then we have minus 8. So we have grouped like terms. So let's simplify. This gives us 10x. This gives us minus 13y. And then this gives us minus 6. So let's look at the second one. Number 2. 9x squared y plus 6xy squared plus 2x squared y minus 7xy squared. Again, we need to group the like terms. So 9x squared y, and then this comes here plus 2x squared y, and then we have plus 6xy squared minus 7xy squared. We have grouped the like terms. So we add this to this, it gives us 11x squared y. We subtract this from this, it gives us minus 1xy squared. Multiplication and division of algebraic expression. Okay, in this, we make use of the laws of indices, or we say the basic rules of indices, which are, if you have a to the power m times a to the power n, since the bases are the same, you maintain the common base a, then you add the exponents, which is m plus n. So we have an example to be 2 to the power 2 times 2 to the power 3. The bases are the same, so we maintain the 2 and add the exponents, which gives us what? 5. So when we evaluate this, it will give us 32. Let's look at the second law. A to the power m divided by a to the power n is the same as writing it to be a to the power m divided by a to the power n. We maintain the common base, which is the a, and then we subtract the exponent, so m minus n. So example is having 3 to the power 3 divided by 3 to the power 2. The bases are the same, so we maintain a common base, and then we subtract the exponent. So 3 minus 2 gives us what? 1. And anything to the power 1 is that same thing. And then let's look at the third one, the last one. 3. A to the power m all to the power n. Then we multiply the exponent, so a to the power mn. So example is 2 to the power 3 all to the power 2. So this gives us 2 to the power, multiply the exponents, which gives us 6. And this will evaluate to 64. Okay, so number 1, simplify this. So this is equal to, we multiply the numbers, so 3 times 2 will give us 6. And then let's look at the x. X, the same base, so we maintain a common base. And then the exponent we are multiplying, the exponent is 2 here, and then the exponent is 1 here. So 1 plus 2, 3, so to the power 3. Now let's look at y. We have y here to the power 1 times y here to the power 2. So we maintain the common base, which is y, and then we add, so to the power 3 as well. And then times what? Z. So number 2. The number 2 is minus 2s t to the power 4 times 8 s to the power 6 t to the power minus 2. So minus 2 times 8 will give us minus 16. S to the power 1 times s to the power 6. So we maintain the common s, and then we add the exponents, 1 plus 6 to the power 7. And then t times t, we maintain the common t. This is to the power 4, this is to the power minus 2. So it's going to be 4 minus 2. So it is going to be to the power 2. Let's look at the third one, which is number 3. It is 81 x to the power 2 y to the power 3 divided by 9x to the power 2 y. Okay, so this is equal to 81 x squared y to the power 3 divided by the 9 x squared y. 9 goes into itself 1, goes into 81, 9. So the final answer here is equal to 9. Now we have x here, we have x here. So it's going to be x. The common base, we've maintained it, and we are dividing. So it's 2 minus 2, so to the power 0. And then here we have common y. So we maintain the y as the base. And then 3 minus the 1, so it is 2. Now, in indices, a number to the power 0 is equal to 1. So x to the power 0 is 1. So 9 times 1 times y squared. So it will give us 9y squared. So number 4. So this gives us 5x to the power 3 y squared divided by minus 30 x to the power 5 y to the power 3. 5 goes into itself, 1 goes into 36. So this gives us x to the power 3 y to the power 2, and we have 1 here, over 6 x to the power 5 y to the power 3. Now, we maintain x, the same base, xs, we maintain. And then we subtract 5 from 3. So 3 minus 5 will give us minus 2. And then we maintain the common base y. And then 2 minus 3 will give us minus 1. Okay, so it's going to be 1 over 6, because there's already 1 here, and then this is over 6. Now, in indices, you don't leave your final answer with negative exponents like we have here. If it is negative, you bring it down as a denominator, and then the negative will change to positive. So it's going to be 1 over 6, and then this becomes 6 to the power 2, and then this, when it drops to the denominator, it becomes y to the power 1, but you don't write. So this is the final answer. Mistake here. The mistake is we have negative here, and then finally you don't leave the negative at the denominator, bring it to the middle. So the final answer is 1 over 6 x squared y. Removing brackets. Similar terms are put into brackets. So before you can solve, you need to remove brackets. So we remove the brackets by applying the distributive law. That is, we expand, simply put. So this is how it is done. The ones outside the bracket, for instance, 3 into 2x minus 6. There is multiplication here, but it is not written. So it's going to be 3 here outside times all the terms in the bracket. So it's going to be 3 times 2. So it's give us 6 what? X. 3 times minus 6 will give us minus 18. Minus 2 times minus 5x will give us minus 10x. Negative 2 times negative 6. So negative times negative will give us positive, but in this case 12. So here too, we group like them as before. So 6x minus 10x minus 18 plus 12. So when we simplify, we are going to get minus 4x, and then this one will give us minus 6. Let's look at a second one, number 2. The second one is 3a, and I'm bringing the square bracket, which is the bigger one, then into 2a plus 4b, bracket closes, plus 3 into 2a minus b, bracket closes, bigger bracket closes. Okay, so this is equal to, now here we have 2 different types of brackets, the square bracket and then the ordinary bracket. They all serve the same purpose, but when you are nesting brackets, it's better to bring the square ones outside. So this becomes 3a. Now, always you simplify the ones in bracket first. So we are going to simplify these ones first. So this, then we introduce the square bracket. Now, there is 1 here. but we don't write the 1. So 1 is going to multiply all the terms in the bracket. So 1 times 2a is 2a. 1 times 4b will give us 4b. We are done with this. This 3 times 2 will give us plus 6a. And then 3 times minus b will give us minus 3b. So this is equal to 3a into, now we simplify the terms in the bracket. So this and that will give us 8a. And then 4b minus 3b will give us plus 1b, which is b. Now, we multiply by expanding. 3, 8 gives us 3, 8, 24. So 24a squared plus 3 times b, 3a times b, so 3ab. Multiplication of two binomials. Binomials are two terms. So algebraic expression with two terms is a binomial. An example is m plus n is binomial. So we are multiplying these two binomials. So we keep the 4x times the whole of the second, which is 3r plus 2q. And then we pick the second one, which is plus 2y times the whole of this, which is 3r plus 2q. So what do? We multiply by expanding. So 4 times 3, 12rx plus 4 times 2, 8qx. 2 times 3 plus 6 ry. 2 times 2 plus 4 qy. So there are no like terms to simplify. So this is the final answer. So let's look at number 2. So for the second one, we have bracket begins 3x minus 2y. And then we have another bracket 3x plus 2y. So 3x times 3x plus 2y, then minus 2y into 3x plus 2y. Now, 3x times 3x, 9x squared. 3x times 2y plus 6xy. Minus 2y times 3x gives us minus 6xy. Minus 2 times y times plus 2y gives us minus 4y squared. Now here we have like terms in the middle, so let's simplify. 9x, this will give us 0. 9x squared minus 4y squared. So that is the final answer. So let's look at the third question. So 2x times x minus y plus y into x minus y plus 2x into x plus y minus y here into x plus y. Okay, so let's expand. So when we expand here, it gives us 2x squared. This gives us minus 2xy. This gives us plus xy. This gives us minus y squared. This gives us plus 2x squared. This gives us plus 2xy. This gives us minus xy. This gives us minus y squared. So with this, let us simplify the like terms. So this and this are like. So 2x squared plus 2x squared will give us 4x squared. Now, minus 2xy plus xy will give us minus xy, plus 2xy will give us xy, minus xy will be 0. So we have this y minus y squared minus y squared. So that will give us minus 2y squared. Number 4, pay closer attention to this because it is not like the first one because of the negative here. The negative here affects everything here. So pay attention. So we have 5a into a plus b, and then minus 3b into a plus b. And then here minus, so pay attention here, we bring bigger brackets, and then we pick the 2a into 2a minus 2b, and then we pick the plus b into 2a minus 2b. We close this, and then we close the bigger bracket. We have this times that gives us 5a squared plus 5ab. This times this gives us minus 3ab. This times this gives us minus 3b squared. And then minus, we introduce the bracket. This times that gives us 4a squared. This times that gives us minus 4ab. This times that gives us plus 2ab. This times that gives us minus 2b squared. So this is equal to 5a squared. We simplify the middle one. 5ab minus 3ab will give us positive 2ab minus 3b squared. Minus into, we simplify here, 4a squared, and then this will give us minus 2ab minus 2b squared. So here this is equal to 5a squared plus 2ab minus 3b squared. Now, let us expand. This times that gives us minus 4a squared. Negative times negative gives us positive 2ab. Negative times negative gives us positive 2b squared. So here, let us simplify like terms. Here we have 5a squared minus 4a squared. It will give us a squared. We have 2ab plus 2ab, which will give us plus 4ab. And then we have minus 3b squared plus 2b squared, which will give us minus 1b squared. So this is the final answer. Subscribe, like, share, and discuss with your friends. Thank you.